All right, so yesterday we reviewed a couple of formulas for circumference. We talked about that circumference can be found if you're given the radius or if you're given the diameter. So the diameter would just be pi d, and then the radius would be 2 pi r. And then we got the equation for the length of the arc. So the length of an arc length, equals the measure of the arc over 360 times circumference, or the measure of the arc over 360 times pi d, or the measure of the arc over 360 times 2 pi r, because those are all interchangeable. So this question is asking for the circumference. I just have to do 2 pi times the radius, which would be 13. If left in terms of pi, it would be 26 pi. So again, on the quiz, you're going to get some that ask you to keep it in terms of pi, and then some that ask you to use pi to find the decimal. You could even see, like, pi is 3.14 and have to multiply that out. So if I just did 26 times pi, you should get 81 point, and I'm going to round it to 1 decimal place, unless it tells me otherwise, 81.7. So make sure you can get to here and to with the pi. Questions on that one? Okay, then we got to the radius if you're given the circumference. So circumference equals 2 pi r. If the circumference is 48, 2 times pi times the radius. I can either start by dividing by 2, this would be 24 equals pi r, divide by pi. And without a calculator, I would leave it as 24 over pi. With, I would find that it's 7.6. Questions on that one? Okay, now we're getting to the indicated measure being the length of the arc. So the length of the arc would be the measure of the arc, so the measure of arc AB over 360 times the radius is what's given, so times 2 pi r. So the measure of the arc is the same as the angle, which means that AB would be 55 times 2 times pi times the radius, that's 9. And then I want to simplify this as much as I can until I get to the part where I have to use a calculator, because there are going to be times when you don't. So if that's the case, then I can say, okay, 9 goes into 360 40 times, 2 goes into 40 20 times, and then 55 and 20 are both divisible by 5. That's 11 and 4. So I can get all the way there without needing my calculator. And then if it does say to round it to the nearest tenth, I would do 11 times pi times 4, which is 8.6. And this time it's in centimeters. Okay. The unit is right on it. Alejandro.
Isn't there a second formula you could use to find the length of an arc?
I mean, just 2 pi r can be substituted in as pi d.
But wasn't there one on the keynote that was it was length of arc over 2 pi r equals
The measure of the arc over 360? Yeah, so that's just that transformed. Like if you just divide the length of the arc by 2 pi r, that would be good if you're trying to find the measure of the arc.
But could you use it to find the length?
Sure. Yeah, it's the same equation. They just set this, this is what it normally equals, right? They just took the 2 pi r and divided it on the other side. So it's the same thing. All right, total circumference of the circles. So there's 2 circles here. Are they congruent circles? How do you know that? So the diameter here is 16, which would be here is 16, right? If I look at it the other way, if this is 32 across, they're each still 16, okay? So these are 2 circles that are the same. I could just find 1 and multiply by 2. What's the radius or the diameter? Let's start with the diameter. What's the diameter of each circle? 16. So if I wanted to use the circumference as pi d, it's just 16 pi for each circle. Double it, and it's 32 pi. So without a calculator, it looks like that. And then with, it's 100.5. This, again, gave you a measurement of centimeters. Questions on that one? All right, find the indicated measure. This time you want the radius. So this time you're given the length of the arc, you're given the measure of the arc, what you're missing is the radius. So if the length of the arc equals the measure of the arc over 360 times 2 pi r, 42 would equal 110 over 360 times 2 times pi times r is my unknown. Simplify it as much as you can. So 2 goes in 360 180 times. I can cross through the zeros. I get 42 equals 11 over 18 pi r. I can multiply both sides by 18 over 11. So it cancels here and here. 18 times 42 is 756 over 11. And then I have to divide both sides by pi. So 756 divided by 11 divided by pi is 21.9. Questions on that one? Okay, this one says find the circumference. So this time they gave me the length. They gave me the measure of the arc is 150. So if length equals measure of the arc over 360, it's also as simple as just writing dot C, right, which is times the circumference. So I know the length is 92.8. I know the measure of the arc is 150. I can cross through my zeros. I can reduce it even further. So that could be 5/12 C, and then I multiply by 12/5 over here, and circumference equals 12 times 92.8, which is 1,113.6 divided by 5, 222.7. Questions on that one? So we're going to add to those formulas. So the first section is circumference and arc length. This one is areas of the circles and areas of a sector. Okay, so just like the circumference relates to the arc length, the area of a circle relates to the area of a sector. So hopefully we start with her like yesterday. Area of a circle is pi r squared. So if you're keeping a list of formulas, do circumference, do arc length, do area, and then in a moment we're going to add area of a sector. Okay, a sector of a circle is a region bound by two radii and their intercepted arc of the circle. So where the arc length is like the crust of the pizza, an area of a sector is like the actual piece of pizza, how much space that piece takes up. So the two sides are the radii, and then the outer bound of it is the intercepted arc. All right, so the next equation is the area of a sector, okay, which is the measure of the arc over 360 times the area of the circle instead of circumference, which is pi r squared. So if you think about what you're doing with these two different types of measurements, the arc length is finding a portion of the circumference, which is the ring around the circle, and the area of the sector is finding a portion of the area of the circle. So we use circumference for arc length, and we use area for area of a sector. Okay, measure of the arc over 360 times pi r squared. Okay, so it says the radius of a circle is 3 centimeters. Find the area of the sectors determined by the given arc and leave answers in terms of pi. So we're going to kind of practice doing that where you're keeping it in terms of pi. So for all three, or all four of these actually, it's the measure of the arc over 360 times pi r squared. And it gives you r is 3. So 50 over 360 times pi times 3 squared. And then just start reducing it as much as you can. I can cross through the zeros. 5 over 36 times pi times 9. 9 goes into 36 4 times, and I get 5/4 pi. And this time the units would be squared because it's area, centimeters squared. So same thing for B. Measure of the arc over 360 times pi. We now know it's 3 squared, which is 9. Cross through the zeros. That becomes 1/18 times pi times 9. 9 goes into 18 2 times. So this is 1/2 pi, or pi over 2 centimeters squared. Area would do centimeters squared. So this, like, across to here, 3 goes into both these, 7, 12, and then 9 and 3, or 3 goes into 9 and 12. Try to get 21 over 4 times pi, centimeters squared. And it doesn't matter if the pi goes after the fraction or in with the numerator, as long as you don't put it in the denominator, okay? So that 21 over 4 times pi is 21 pi over 4, or 21 over 4 times pi. They can be separated. Just don't put the pi in the denominator. Raise your hand if you got them both right. Good. Okay. Just be careful on, like the simplification of it. It's easy to make a silly mistake. Questions so far? Okay, so this one says, find the area of the region bounded by segment AB and arc AB. And leave the answers in terms of pi. So this is where the trickiness occurs. You're going to get shaded regions. You're going to get parts in which you have to try to find out what shape they are and find the area of them, okay? So this says bounded by segment AB and arc AB. Is that a sector? Is that an area of a sector? No, right? I can't just find it using that equation, right? You with me? Is that a shape in which you know how to find the area? No. So how could we find the area of that shape?
Isn't AB 120, the arc?
The arc is 120, yep. So if you want to use the area of the sector, it's going to give you this whole piece. Right? If we use that formula. How do I cut out the piece I don't want? How do I get rid of this piece? The triangle, right? We know how to find areas of triangles. Yeah? Yeah? Do you know how to find the area of a triangle? 1/2 base times height, right? Okay. Does everybody see that? That if I find the area of that whole sector and I subtract from it the area of that triangle, I get that little missing blue spot that we need. You with me? Because there's going to be some, like, little higher level thinking here. We've got to figure out the shapes aren't always going to be the same. You got to figure out if I take away that part, then I'm left with what I need. So you got to figure out how to get there, okay? So I know if I find the area of the sector, oops, daisy. If I find the area of the sector and I subtract from it the area of the triangle, then I end up with the piece I want. So area of the sector is this whole piece here. The measure of the arc, which is 120 over 360, times pi times the radius, which is 6, squared. I'd get 100. Well, I can cross through the zeros, make it easier. So it's 1/3 pi times 36, which is 12 pi. So the area of the whole sector is 12 pi. Now I got to find from that the area of that triangle. So the triangle, which looks like this, and this is 120 degrees. So I know the area of a triangle is 1/2 base times height, but do I know the base and the height? No. The height has, how do you know it's the height? How do you know the height of a triangle? How do I show the shortest distance between 2 points? What has to be special about that segment? How do we show distance? Think about how we showed the distance from the center to the chords of a circle. How do you show distance there?
With a line.
With a line, but what kind of line? What had to be special about it?
Has to be a right angle.
It has to be a right angle. Goodness. So I need this distance here. What did I just do with that 120? Split it into 2 equal parts. And the only reason I know that is because the other 2 sides are congruent, right? So I just made it into 2 30, 60, 90 triangles. You with me?
So we have to
Good
do
math.
the Pythagorean theorem?
No. Worse.
What's that?
30, 60, 90 triangle.
What's the tangents?
No. So I have 2 triangles that have a right angle and a 60 and a 6. So remember I said these are never going to go away. I meant it.
What is it?
Okay? What's the relationship in a 30, 60, 90 triangle? Do you remember?
No.
Clearly you don't remember. It's A. A close. Opposite the 30 is A. Opposite the 60 is A root 3. And opposite the 90 is 2A. Sorry.
So it's 3?
So this is 3. And this is 3 root 3. So from here to here is 3 root 3, which makes the base of this triangle 6 root 3. And the height of this triangle, 3.
It's going to be like an actual problem?
You could see, I'm telling you right now, the 30, 60, 90 triangles are not going to go away.
On the quiz?
So on the quiz, there are going to be shapes in which you have to figure out what they are that are not circles. Okay? Yes, there's going to be some, sorry. Actually, I'm not sorry. I don't apologize.
Why is it 6 root 3?
Just the part from here to here is 3 root 3, right? Because I split it into 2 triangles. So I got to find the area of that triangle. Yep. So area of triangle, 1/2 the base that we just found, which is 6 root 3, times the height that we just found was 3. So this is 3 root 3 times 3 is 9 root 3. Without a calculator, can you combine those? No. So without a calculator, you would leave it there, especially the directions said leave it in terms of pi. If you had a calculator, then you would go to the next step and multiply 12 times pi and subtract from it 9 root 3. You are going to have a question that has area of a shaded region that is not the shape of a sector on it. You got to try them eventually. You got to stop being, man up. Stop being little wusses about it. Okay? Well,